Hello everyone! For today's video, I am here to discuss the causes of the plate movements and the evidences that the Earth's plates are moving through the following ideas. First, continental drift theory. Second, seafloor spreading. And lastly, Earth's magnetic reversal. Alfred Wegener is recognized as the inventor in 1912. He proposed the continental drift theory, claiming that the continents are progressively migrating around the Earth. Pangaea, a Greek term meaning big continent, was once a vast landmass, meaning everything on Earth. It explained how continents shift position on Earth's surface. Continental drift also explained why look-alike animal and plant fossils and similar rock formations are found on different continents. Cause of continental drift theory. Plate tectonic theory adequately explains the causes of continental drift. The outer shell of the Earth is made up of plates that move slightly every year. Convection currents in the mantle are triggered by heat from the Earth's interior, causing this movement. Over millions of years ago, this steady migration forced that once combined supercontinent to divide into the 7 continents we see today. First evidence, geological fit. The fit of large-scale geological characteristics on different scales is referred to as geological fit continents. The coastlines of South America and West Africa appear to coincide, but the rock terrains of the two continents, in particular, confirm this. Second evidence, fossils of ancient organisms. It demonstrates how Alfred Wegener plotted the ranges of the 4 Permian and Triassic fossil groups and utilized them as a guide. Continental drift and land bridging are supported by biogeography evidence. Some of the fossil evidence discovered on the continents includes Mesosaurus, Listosaurus, Cygnognathus, and Glossopteris. Mesosaurus, a type of reptile. Similar to the modern crocodile, it lived during the early Permian period from 286 to 258 million years ago. Cygnognathus, also known as dogjaw, was a mammal-like reptile, roaming the terrains during the Triassic period from 250 to 240 million years ago. Lystrosaurus, also known as shovel reptile, relatively dominant on land during the early Triassic period 250 million years ago. Glossopteris, the most important fossil evidence found in the plant, emerged during the early Permian period 299 million years ago. Third evidence, matching of rocks. The Appalachian Mountains in eastern North America are one example. The recognizable geological layers of South Africa's Caro system corresponded perfectly with the Santa Catarina system in Brazil, and the mountain ranges of Brazil and Ghana agreed across the Atlantic Ocean. Fourth evidence, glaciers carvings. Glaciers cut rocks and leave traces as they advance. Scientists provide evidence in this case have the ability to calculate the direction of travel of each continent. Fifth evidence, coal deposits. The presence of coal deposits in Antarctica suggests that it was formerly located in the region of the Earth where the temperature is suitable for complex life forms, such as plants and tall trees. Coal forms from decomposition of living things in tropical areas. Now, let's proceed to seafloor spreading. This notion was eventually dubbed seafloor spreading. Harry Hammond Hess envisioned oceans growing from their cores with molten material or basalt pouring out from the Earth's mantle along mid-ocean ridges. Seafloor spreading is a geological phenomenon in which tectonical plates, large slabs of Earth's lithosphere, split away from one another. Mantle convection is the cause of seafloor spreading and other tectonic activity process. The less dense material rises, frequently producing a mountain or raised portion of the seam. Cause of seafloor spreading. Divergent plate boundaries cause seafloor spreading. Heat from the mantle's convection currents makes the crust more flexible and less thick as tectonic plates progressively migrate apart. Less dense material rises, frequently producing a mountain or raised portion of the seam. The crust eventually fractures. Evidence of seafloor spreading. Several sorts of ocean evidence supported Hess' notion of seafloor spreading. Evidence from molten materials, magnetic stripes, drilling samples. These findings encourage scientists to reconsider Wegener's idea of continental drift. And lastly, Earth's magnetic reversal. The magnetic reversal of the Earth, often known as the magnetic flip, occurs when the North Pole becomes the South Pole and the South Pole becomes the North Pole. Magnetic reversal has occurred several times in the past. The appearance of the magnetic patterns of magnetic rocks help explain magnetic reversal. Our experts can use these magnetic patterns to determine the ages and rates of transport of materials from the mid-ocean ridge. Cause of Earth's magnetic reversal. Since the forces that form our magnetic field are in constant flux, the field's intensity waxes and wanes throughout time. This causes the Earth's magnetic north and south poles to gradually change and, every 300,000 years or so, totally swap positions. Evidence of Earth's magnetic reversal. Examining the geologic record reveals evidence of magnetic polarity reversals. When lavas or sediments harden, they frequently retain a mark of the magnetic field that existed at time of the deposition. As incredible as it may appear, the magnetic field flips over on occasion. Basalts, sediment cores, reefs from ocean floors, and sea magnetic anomalies all have evidence for these geomagnetic reversals.